Hi, in this tutorial we are going to solve a question related to naming of carboxylic acids and nitriles. Let's look at the question. The question asks us, give IUPAC names for the following compounds. Let's start from the first one. The first one, if you look at the functionalities, it has a carboxylic acid functionality and an alkene functionality. When you have an alkene functionality, you need to decide whether it's a cis, trans, or E or Z alkene. And if you look at this particular alkene, we have 1, 2, and 3 substituent. We have to use EZ system. Okay, but before saying EZ system, let's number the longest chain for carboxylic acid. Then let's start naming it. And if you look at here, we have 1, 2, 3, 4, 5, 6 carbon long chain we have. So it's a hexane, and we have to say it's an hexanoic acid. Carboxylic acid, we have to add oic acid, but we have here an alkene, so we have to say hexenoic acid. So let's write first. This is hexenoic acid. So after that, we have to look at here. We have a substituent at fourth position, and it's a methyl group. So this is going to be 4-methyl hexanoic acid. And here we have to tell the nature of alkene, whether E or Z or cis or trans, but we have already concluded that we have 3 substituent around double bond, so we have to use EZ system. For that, let's look at, if you look at this carbon on the alkene functional group, we have a methyl and ethyl, so this part has more priority. And let's look at the other carbon on the other side of the double bond. We have here a hydrogen, and we have this group. This group has more priority. So more priority groups are on the opposite face of the alkene. So this is going to be an E alkene. So we are going to write here E 4-methyl hexanoic acid. You can specify also 3E, because where is the location of double bond? 3E. Okay. When you have an alkene and when you have a carboxylic acid has to be should have priority over the alkene, and here we have to specify the location of alkene. So when you specify here, you don't have to say 3E. So let's just move 3E, and let's move all the way this part, this one here. Then we have to say 4-methyl. Let's write again. So we have to type E back, E 4-methyl. Then we have to tell the location of double bond. It is 3-hexanoic acid. So this is the complete correct name. We can just erase this one, and we can move this one over here. Okay, let's move it here. So let's say this is number 1. This question option, let's say A, and this is A. Let's move to B. B is a carboxylic acid, but carboxylic acid functionality is next to a cycloalkane. So this particular type of cycloalkane carboxylic acid, when we name that, we have to say this cycloalkane then we have to say it's a carboxylic acid. Cyclohexane carboxylic acid. In this particular case, this is a cyclohexane carboxylic acid. But when you look at here, we have two chiral centers, and let's just look at the chiral centers. This first carbon, there is here a hydrogen going behind the plane, and there is another hydrogen on this carbon, which is the same, going behind the plane, paper plane or screen plane, you can say. And we need to decide whether this chiral center is R or S, and we have to do the same for the second chiral center. Let's do for the first one. The first one, we have here a number 4 hydrogen, and this carbon should be numbered as 1 according to Kahn-Ingold-Prelug rule, and this carbon has to be number 2 because like this carbon and that carbon is same, but next carbons, this carbon is bearing a methyl group, whereas this carbon is bearing two hydrogen groups, two hydrogen atoms. That's the reason why this is number 2 and this is number 3. And if we look at from 1 to 2, 2 to 3, we go clockwise direction, so this particular chiral center is R. And let's do the same for the second chiral center. Hydrogen is number 4, and when we look at this carbon, it has to be number 1. This carbon is number 2, and this carbon has to be number 3. And if we go to 1, 2, 3, it is counterclockwise, and hydrogen is facing behind the plane, so this has to be S. So basically first carbon is R, and third carbon, why this is third carbon, we are going to discuss it, is S. Then let's look at now let me use the green marker. So how do we number when we have a cycloalkane carboxylic acid? We have to start from the carbon on the ring having the carboxylic acid functionality. This has to be number 2 because there is a substituent here. We have to go that way. 3, 4, 5 and 6. 6 is hexane, cyclohexane carboxylic acid. And let's look at 3 is S, 1 is R. So when we write name, so we specify the location 1 R and we put comma, 3 S, we close the parenthesis, we put a dash. Then this is we have 3 methyl, right, as a substituent. 3, first letter is capital, 3 methyl cyclohexane. I don't have space here, but I'm going from here. Cyclohexane without space carboxylic acid. Okay, so we specified the location and configuration of chiral centers. Then we specified the location and substituent. Then we said this is a cyclohexane carboxylic acid. Okay, this was B. Let's say this is B. Let's look at C. C is a nitrile. And why it's a nitrile? Because it has carbon nitrogen triple bond functionality. So we have to start numbering from this carbon, and we have to find the longest chain. 2, 3, 4 and 5. 5 is the longest, so this is a pentane nitrile. But we have to say what kind of substituents we have. At the second we have ethyl, and at the third we have methyl. So we have to say ethyl first alphabetically. So this, let's write here C. This is 2 ethyl and 3 methyl pentane nitrile. So alkane nitrile. Okay, let's look at the last one. D is again a nitrile, but nitrile functionality is next to a ring. So when we have this situation, we say carbonitrile. In carboxylic acid, it's cycloalkane carboxylic acid. Here, cycloalkane carbonitrile. So let's look at here. Let's number the carbon. So this has to be number 1 next to nitrile group. This has to be 2, 3, 4, 5. So this is cyclopentane carbonitrile. And let's look at, we have a substituent at 3rd position. So I'm going to write here D. This is 3-isopropyl cyclopentane carbonitrile. That's the name of that's the IUPAC name of this molecule. Thank you so much for watching this video.